Now we are going to create crankshaft 3D part modeling using NX CAD. Okay, first let's start with the sketch and choose front plane for creating crank pin journal. Okay, this front plane, let that direction go towards Y direction. Let it go towards Y, but not this way. Okay, this one looks nice. Let it look in front of us, as we are going to see from there. Okay, and this crank pin journal is just a shaft like feature. Okay, at 35 diameter. Okay, 35 So we have created one circle. That's enough for this feature. Okay, let's finish this sketch. Okay, now let us extrude it. And in the extrude, we have selected the curve and specified the vector automatically. But this time, this vector should go both way, this way as well as that way. And this should be 70 Okay, let all rest all things be okay. Is done. Okay. Now for creating the counterweights, we need a datum plane at a distance away from the front plane 20 Okay, the distance is offset distance 20. Okay, now to see this datum plane, you can go to part navigator and select this datum plane and draw a sketch. Create a sketch first. Let me check once again, because it's going to create some problem later. Let me choose this datum plane. Let me check first its sketch, and then let me choose that plane. And this time, let's see, we used to have the front plane towards us. Let's keep the same way around. Otherwise, it goes the X direction. Let us reverse this vector for orientation reference. Otherwise, let it go that way. See the difference? We will draw this and extrude it that way. Okay. Whether we have chosen the result is in the downward direction, that I don't want. Then we have created. Let's exit this sketch. Let's see the first sketch how we have created. Edit the sketch. Yes, it goes up. Same thing we have to do here. How we are going to do, let's see. Let's hide this, extrude, and then again let's create a plane. Let us visualize that. We need a plane, datum plane in this. Okay, now you see this should follow the other way around. Okay, this is also okay. But let me see whether it goes. Okay, it go. Why that? Okay, then let's see how it goes. Let me sketch it using this plane. Yeah, using this plane. Now this insert reverse the orientation. Z goes other way around, but I want to place the normal. Okay, sketch. Now it's okay. Yes, we have this. Now we are going to draw an arc from midpoint, arc from center, arc from center at a distance of 25 radius. Okay, and it goes about the axis 180 degrees angle. Let's close it, and I'm going to draw a line, a straight line. So it goes down somewhere. Let's keep it somewhere, and then let's draw one more line. Yes, this is not equal. Okay, let's keep somewhere here and finish it. Let's finish the sketch. Now you see the color of the lines. To change this color of the line, this is an approximate system generated dimension. We have to make that dimension stronger. Okay, done. And the same way, if you give equal, make these two equal, make this one and this one equal. Okay, cancel it. Now this also has turned black, and we are going to use this line from midpoint now. Okay, use somewhere here. Don't snap to any features. It needs to be constrained using dimensions. This we need 45 mm. Okay, and then this line we will make it reference. Sometimes this will create a problem. Now again we are going to create an arc using from center. This is now, in this case, it's very convenient at a radius of 62 mm. Okay, and it goes downward from 270 to 360, almost 180 degrees. Enter it. Now this line we may not need it because it will disturb the model, because we are going to create a line. You see, line from this point to this. Okay, line from, and then you see anything else? Yes, we need separate line from this point to this point. Okay, now you see any features, any features. I think this one is wrong. Okay, this circle, this line should go 5 mm downwards. Otherwise, let's not delete it. Let's keep it. Now we are going to use the another feature, offset. Offset by 5 mm. It's not working, you see. That's why we delete it. Okay, let's undo everything. Let's offset this midline by 5 mm. Okay, cancel it. This 5 mm. Okay, let's keep it, no problem. and let's corner this. Let's corner this with this. Let's corner this with this. Okay. Again, let's corner this with this, and we need a line here. Okay. Let's corner this. Let's corner this with this. Now it's okay. What's coming in this midpoint line? Again, one circle. That circle should be 32 mm. Okay, let's close it. Now let's skip everything set us. Otherwise, let's skip this hole to assemble the Crankpin journal. Okay, now this is, you see the color of this. It's looking in. Now you see, okay, no problem. We have to create without any reference there. Okay, now this dimension is gone. Yes, let's make it stronger by double clicking it and entering it. We should ensure by giving this value, double check it, but this is over constraint. Okay, and this radius we have given. Okay, and this radius we have given, but its dimension from this center point to this axis, from this center point to that axis is 50 mm. Okay, and what else? Whether this is a difference between these two, it's constraint. Let's constrain this to coincident with this axis already there. This axis already there. Okay, let's see how it works. No, it should not be. See, this is what the problem with manufacturing softwares. Okay, anyway, we have created the features. We are going to see any problem with this. Sketching automatic constraints. Okay. Now we are going to create another extrude at a distance of only 15 mm. Okay, the YV. But we are going to unite this. Okay, let's keep it as it is. Anyway, let's unite it with this part with this extrude. Okay, now we have created the journal. With this journal, we are going to do two more. Why the sketch is getting disturbed? Because we don't need this. Edit it. What's happening? We have not done anything in this two sketches. They are not completed or we are not done. It's there in the history. So we can delete these two. Unwanted. We should not repeat some mistakes like this. Okay, another feature what we are going to create is extrude. Let's directly take extrude and in this plane, okay, let's draw using line some features like this, somewhere up to this, and then up to that, and match it. This we have not done any proper calculations, but anyway, let's keep it as per the drawing. This is 30, so it looks black, okay, and then from this point to that point, it's 80. Will it look? Yeah, from this point to this, okay, let it be whatever it is. Oh, 65, let us give. But anyway, 60 is enough, I think. Okay, what's happening here? This is black. Now this angle, instead of giving this angle, let's give this point to this edge. Okay, that is 20 plus 3 mm, 23 mm. Okay, click OK. And the angle, of course. Okay, this one, let's make it 10 degrees. If it is 10 degree, then this one is not. This one should be. This one should be 3 plus 12. Okay, this 60 is getting stretched because we have chosen the wrong direction. We are going to select this side by 12. Okay, no problem. Let's make this horizontal. Oh, it's jumping here and there because we are not constrained the corner point. This one is okay. We have chosen from this point. It's constrained. Let's keep it as it is. Everything looks black. Okay. Now with this sketch, we are going to symmetrically extrude by around 60 mm, and instead of uniting it, I'm going to subtract it. Okay, it's done. And again, I'm going to create a sketch using this plane for extruding. Right? We have to extrude. Yes, it's extrude. This is a balanced crankshaft. So we have to create a sketch, not in this, not in the face, but in the datum plane. Is it going correct? Let's reverse the normal. Yes. Okay, now I'm going to create a rectangle at 10 mm width by 45. Okay, it's done. Now everything comes automatically. And I'm going to constrain this by 5 mm. Okay, and I'm going to constrain this to this axis by 20. Okay, now rest all comes automatically to make the sketch black. That means it is completely constrained. Okay, let's finish the sketch. Before that, let us edit those sketch again. Here at the bottom, we need another feature. Let's create it from this point to somewhere some 15 mm. Okay, to this. Again, I'm going to create. Okay, again, I'm going to create this point. This to touch this. Let's keep it. Okay, close it. Let's trim the unwanted edges. This is how they are balancing the crankshaft. Now everything looks black. Let's exit, finish the sketch, and now extrude it. Okay, but not to subtract but to unite at a distance of only, what is the distance? It's 20 mm. 15 mm, right? Okay. It's a balanced crankshaft. I'm going to create a mirror feature. Rest all it's okay. With the add-on features we should do at the end after creating all the sketches. Okay, let's mirror this feature. See, I'm going to mirror this feature, only this feature, and this feature, and this feature. These three features we have created, and the plane is this plane. Apply it. Okay. Now it seems the crankshaft comes to a shape. Now I'm going to do a revolve. Okay, let me revolve a right side. Yeah, it looks okay. Where is that sketch appearing? No, it should be in the right. This is what I want to see, the sketch. Okay, in this I'm going to create a sketch. Okay, let me draw a midpoint line somewhere here. Okay, and close it. Let me dimension this line, okay, at 45 mm, where my center hole for shaft goes, and make this as center line or reference line. Okay, later we will delete that also because it looks otherwise. Okay, in this point about this axis, let me extend some more, and then we will delete it. I'm going to create a sketch. Am I right? From this point to this point, it is 35, right? Yes, at the 45 we have a shaft. I'm right, I think. But this should go somewhere else. Okay, let me try from here to here at 2 mm, no problem. And let me go down by 1 mm. And let me go this way approximately some 10 mm, no problem. Again, let me go down by 1 mm. Okay, then let's go towards somewhere, and this goes down from 5 mm down. Okay, let's go down by 5 mm. This works. It's not. It should be 2.5 mm, not approximately. Let me take 2.5 exactly. 0.5. Okay. Okay. And then let us go for the. Let's go for the not equivalent. Don't allow this to happen anywhere. It's pointing somewhere. Okay, it's parallel to, perpendicular to. Okay, let's skip that, whatever it is coming, and let's go down by 1.5. Okay, and then go this way around, somewhat 5 mm, somewhere approximately, and then let's close it. Okay, let's finish the sketch and start giving the dimensions. We need this diameter, okay, from this to this point. Let's keep it as it is. Okay, this should be 31. Okay, 31 in the sense 15 point, sorry, 32. So 16 mm radius. Okay, we created 16 mm radius. It goes somewhere else. Let's see whether we have done the right job or not. Okay, and then let us give this diameter. This one should be 30 mm diameter, so 50 mm radius. Okay, and this should be, oh no, don't give anything equal. Let's finish it. This one should be, okay, how much? It is 28. 28 means 14 mm radius. Okay, let's give this. Let's give this 25. 25 means 12.5. Enter it. And then let's give this. No. Let's give this to this. Okay. This one should be 25 after 25, 14, 28, 25. Okay, 25 dia. Okay, where we have missed 30, 28, 25, and we have one more feature also. So we have 18 dia. Okay, and this one not ends here. It should go, no, not this. It should go this way around by 1.5 mm approximately, and then by 5 mm down, then it connects. That's okay. Can give it here itself, but anyway, I'm demonstrating how it works. It should be 7.5. Okay, let's leave it. And this 9 mm is 18 mm. Now we have to give the horizontal dimension. Start giving from this edge. We should give from there. It should have a reference. Actually, we should have created this all from this X. But since we are going to revolve it here, we need an axis. Okay. Then, okay. Now the distance, linear distance. From this point to at least this, we will constrain it perfectly. Okay. Let's see. Oh, let's see. It should be 20 plus 15 plus 85 under 120. It should be 120. Okay. Now everything will come one by one. Starting from this. Now let's see. Starting from this point to this point, it's only 5 mm. Okay. Okay. And from this to that, from this to this point, it is 25. Okay. And from this to, okay, from this to this edge, it is 70. Okay. And then, okay, and then to this edge, no, 70 goes not here, 30, 30 mm dia. Okay, 70, this is not 70. Okay, it's 70. Okay, and what is that? I don't know. Let's give this dimension to this. It is okay. Let's give 83 then. 83. Okay. It seems fine here. Okay. Let's give this dimension. Okay, let it go up to 15 plus 2 mm. Okay, let's it go up to 18 mm. Here it goes 3 plus, it's not 80. Let's keep it there as it is. Now everything seems constrained. Let's draw a line from this point to this point, and then let's close it. This is how we should have done it. Okay, now it looks okay, but this should be, it is going to work or not. Center line, okay, but still it needs dimension, and it will overlap with that. I think we should restrict this 40 mm then. Okay, now everything looks black, right? This is where we are going to spend more time. If you are not creating the sketch properly, then you won't be able to create any features. That is the basic thing you should keep in mind. And in this model, we are creating using all the part model features and all the sketches features. Okay, this is fully constrained. There is no issue with the sketch. Let us finish it. Rise tone warning. There is a problem. Why there is a problem? Let's see why there is a problem. This distance we are not mentioned. We have to mention. But there is no way. Is it okay? On this, it seems. Okay. Let's make it one strong. Okay. Okay. Now, no warning. Is there any warning? No warning. That warning will not allow you to create any features. You have to be very careful and patient while creating sketches properly. Okay, now I'm going to specify the vector. This is how you have to create the revolve, and I'm going to select the center point of this feature. Okay, I'm going to specify this point clearly. Now this feature has come, and I'm going to unite it with this body already selected. Okay, so we are creating more than enough numbers of extrudes to learn, and I am going to create one more revolve also. Here what I am going to do, I am going to edit it, because there we are given long distance. Edit this extrude, edit the parameters and the sketch. This one 60 should not be, it should be 45, but it's going down, right? We have constrained it. Let's liberate it. Let's go down and reduce this line, but this one is constrained. I don't want. Okay, let's reduce this by 60 then. Okay, undo it. This one we should not constrain it. Now cancel it. We should liberate it and then give 60. Okay, and let's make this as horizontal. Okay, it seems okay, right? Still, this dimension is not sufficient enough. Is it okay? It's not okay. I'm going to give 68 then. Oh, sorry. I'm going to reduce it to 58 then. It's okay. No, it's not falling with this. And it should match with this. That's why we should ensure that this one is horizontal. But now everything going to fail. Okay. And at the same time, this angle is okay. Not okay for me. I'm going to give 11, or I'm going to give some 11.5. Okay, now it's matched. Let it cut anywhere, no problem. But this one still I'm not. Okay, if I give 60, it folds, right? Yes. Let's keep it as close as much close as possible. Okay, now it's okay. It seems okay. Finish the sketch. I'll refresh it. Yes, this is what I want. Okay, everything has been updated. Now let's save it, otherwise we'll lose it. See, another shaft I'm going to create using Revolve. Revolve. See, the advantage with this type of usage of Revolve and Extrude, the sketch will go inside. The tree, the part navigator will have less number of features here. It will be hidden. It looks nice for me. Again, I'm going to create a revolve. So this time, once again, I'm going to create a midpoint line anywhere, no problem. Somewhere lengthy. Okay. And this line display should look like reference center line, and its distance away from the axis is 45 mm. Yes, I'm overriding it. Now let's start giving sketch, and later we will see if I give this dimension some 300, let it be. Later anyway I'm going to make it 40 only. It will become black. Okay. Now I'm going to use the line command and start somewhere from here, similar to this, and this also 32. Let it go somewhere, and let it go down by 1 mm. Problem, we will give it later. Okay, and then it goes to somewhere here, and it goes down. See, my system has become slow, but anyway, this is the way of creating sketch. Otherwise, if your system is fast, no problem. But if it's slow or fast, you have to be very careful while creating a sketch. You see, I'm going to create a rough sketch. This is just like a rough sketch. By this is not a problem. You can even use it for extruding as it is. Okay, but if you try to give dimension, you see the method I'm using. Otherwise, it will not work for you. See, first I am going to give this diameter. Again, this should be 16 mm. Okay, let's keep it 16. And the another diameter is 30. This one should be 30. 30 means it should be 15 radius. Okay, and wait, the another one is 28. That means it should be 14. 14. Okay, and okay, let's give by point. Let's later give it. And this diameter is 17. Okay, it is not 17. There is one more step there. Let's keep it 17, no problem. And try to finish it. Oh no, not here. not this way around. See, I will explain each and everything. 17 means 8.5. So what's happening with do it? It's linked to something else, that's why we should not have pressed it. Now you see this one is not 10.4. It should be um, there is one more step here. We are not given that. It should be 12.5. Make it. That means 25, 30. No, it should be. There's one more step here. Okay, 30 to certain and okay, 28. Okay, that dimension. Yeah, should give this 28. There is one more feature we are missing out here. After that, this one is wrong. See, if you do like this, then it will be a problem. We have to be very careful. There is a down by okay, whatever it is. And this goes to certain distance, and then there is a taper, and taper goes to certain dia, and again there is a 1 mm down, and then it goes straight and finish that. This is what called each step is a feature from manufacturing point of view. That's why the sketch will not get constrained that much easily if you do any mistake. Again, you see this is not 30, 25, this is 28. Okay, this one is 25. See, if you are not finishing that dimension, it will align with the other dimensions. This one should be 12.5. You see the arrow mark and the anchor. This one it shows the vertical relationship, and this arrow mark shows it goes up. Okay, we have to be very careful. Now after that, since I have not finished this dimension, see that this horizontal relation will apply to everywhere I am touching. If I apply this, touch it, this horizontal relation will apply to that. That's why we have to finish this particular dimension, even though it's slow, no problem. And then let's go to this dimension. This one is now 17 dia. This line shows it's an approximated value. It's not exactly equal to 7.5. So if you want 17 here, then you should enter 8.5. It will become exact value, and it will become black also. That means that's not generated by system, it is confirmed by the user. That's what the design intent means. Okay, and then again there is a diameter here. See, this line is approximated line. Then you have to give 7.5 to make sure that there is a 15 mm dia. Now everything done diametrically, only diametrically. Then we have to do horizontally. This is called vertically. Then we will do horizontally. From this point to this, let's constrain it first. How much it should be? It should be 90, 95. Let's give this way, whether it takes or not. 15 plus 20. Yes, it takes. Yes, I'm overriding it. Let it be. Okay. And this one from now we can give from here, from this to this. Okay, it is 20 mm. 20 mm. This is very strong dimension. Why it's showing blue in this, instead of some khaki color? This is showing blue because there is a hidden parameter. That means there is a calculation there. There is an addition, deletion is there. That's why it's showing as a parameter. Okay. And then from this point to this is where you have to be very careful. I'm selecting this point by end point. From this, if I give, you see, it may get disturbed sometimes. That's why we have to be very careful. See, there is no arrow mark showing. But anyway, this is constraint, so this should go this way. Let's see, this arrow mark showing now. Okay, anyway, it will go because it has the movable edges. Now I'm going to fix it at 30. Now this won't move. This will become black. But this color shows me, informs me that there is a movable edge. Let me see that by selecting this edge endpoint to this vertical line, I'm going to constrain it. See, only this side it can move back and forth. So instead of 50, I'm going to give 47. It's constraining. Okay. Then I have to finish this. Okay. Then from this point, this vertical line to this vertical line. Okay. Okay. Let's uniformly arrange it. Only this one I'm seeing as a okay, and this one should be 80 mm. Okay, now you see that there is a mismatch. This is where we have very careful. This goes where this 80 mm, 47 mm there. Okay, 80 mm goes at 25 dia, correct? At 28 dia starting point. It should be 28 dia starting point, correct? And then 28 dia starts from here, this point. Let's give this one more extra feature, it seems. No, but see, it goes up to starts from 80, right? That means that it should be 80. Okay, then why it is there? But it ends at 85. Okay, let's give some value here. Okay, and then okay, this one has become black. Now this stuff is left. Saffron. From this point to this vertical line, let's move it up. Okay, should be 93 then. 93. Okay, only stuff left is okay. We have closed this point. Let's give this dimension also. Now you see we have come some 2 mm this side away. Let's give 17. So that my goodness, we should notice where it goes. Okay, that one closed 93. Then let's select this. This one is now 2 mm plus. 15 mm this to cover it. So let's give 17 mm. Let it cover it. It should give okay. Then move it up and center it. Okay, then rest all okay. This point to this point vertically and close it. Okay, and now you see there is a overlap of two lines, center line plus this one, that we should avoid because that we have created. That's why I'm going to reduce this midline within this 40. Okay, now is there any issues with the sketch? I think there won't be. That's why it's going. I've taken a lot of time, but see, it's not giving me any trouble. I'm going to specify this vector. The point should be this one. Oh, sorry. Yes, it works fine for me. Apply, that's it. But sketch we have spent a lot of time, right? Okay. Now you see, let's analyze. Let's analyze there from here to this plane distance. Okay, it is 95. So why I'm analyzing it and measuring it, I'm going to create a plane. Okay, datum plane by offsetting this front plane by 95 mm. Okay, apply it. I can move here and there, no problem. I can move it wherever I want to, bigger or better. Okay, no problem. Apply it. Cancel it. Now I'm going to create an extrude. So straight away I'm selecting extrude. The extrude will look for a sketch. That sketch will have this as a datum, and I'm going to see from this side. So let me reverse it. Still I want to reverse it. Reverse it. Yeah, now I'm seeing the sketch. Okay. What I'm going to do, I'm going to create plane. Here I don't be able to see. Okay. One random monocircle. Okay. Let's create some more one rectangle. Okay. The rectangle of 4 mm by 5 mm. Okay. Finish it. Finish it. Okay. Let me view to the normal sketch plane. Okay. Why it's not showing? Okay. Okay. This I'm going to create a dimensions from this to this axis. Okay, this distance may keep it, and may keep it 31 then. Okay, and from the close it, from this to this axis, and may keep it 2 mm. Okay, that's it. It has become black now. The sketch is fully constrained. Let's go. Let's go. Finish it. Okay. Now this I'm going to extrude at a distance of, here it's 0. Here it's 20. Okay, but in the reverse direction. Now instead of uniting it, I'm going to subtract it. Okay, we have created almost all the options here in this model alone. Now I'm going to create one more feature here. See, I'm going to use a circular pattern. We have used a mirror, we have used, okay, this feature only. Okay, I'm going to specify the vector in this. Okay, I'm going to create a point. Okay, and this time 12. If it's 12, it's 30 degrees pitch angle. Then okay. So we have created one approximate spline. No problem. We'll later edit it. And one more stuff what we have to do, we have to create one more extrude, but this time without creating data plane, directly touching the scale surface. But that's not good practice. But anyway, here I'm going to create a slot. Okay, that we will give 5 mm by 4 mm. Okay, done. Okay, now from this point to this, it's just this one is overall 7.5. I'm to consuming leaving 4 mm then, but let me give 7.5 now. 2.5. Sanging. I'm going to give this dimension from this axis. Okay, it's 2.5. Okay, it has become black, fully constrained. Let me finish the sketch and extrude it in the reverse direction at 20 mm. Okay, up to this, subtract it, everything automatically happening. Okay, and the final step, what we are going to do, creating holes and the edge fillets and chamfers. Almost all the features, key features we have used in this part modeling crankshaft. Okay, let me create holes. Hole. Now I'm going to create only on the surface, but that's not good practice. But creating a data break takes me a lot of time here. See, let me choose this point somewhere. Okay, and let me edit that sketch. It is gone. Let me edit it. Oh, let me. It goes the other way around. Cancel it. Yeah, let's see this. What my slow system teaching me. I'm going to edit this feature we have created. Edit parameters and edit the sketch to change the position. Edit the sketch. Now you see everything's approximate. This one should be somewhere around 5 mm. Okay, and this one should be 5 mm. Okay, now it's okay. Let's finish the sketch and see that. Okay, this 5 there, but depth not through body, but the value of some 35 is more than sufficient. Okay, now we are going to create one more pattern here. I can do it mirror also, but let me teach you all the features in this part modeling. The vector is this one. Okay, the pitch is, now you see, let us give something like 42, oh yeah, 42.5. Let's see, specify the point. Okay, why it's asking me the point origin. Okay, this one. Let me see how it goes. We have done a circle pattern, but we should do a linear pattern, man. Okay, specify the vector and create the count, and the pitch should be 42.5, not 4.5. Okay, it's previewed and see that distance should move here. T9, maybe it's 60. Let's see, show the result. It's fine then. This is a linear pattern. Here we have learned circular pattern. Okay. Now one more stuff. We are going to create the hole here in this datum plane now. Same 5 dia. But you see how I'm going to do. I'm going to specify the points. This one and this one, because I have not selected any surface. I'm using already the rigid robust data system. Now I have to dimension these two. Okay, from this point to this point. Okay, it should be 24. Okay, I'm overriding it. And again, I'm going to ensure that these 2 points symmetric to this line. Okay, that's what my requirement. Okay, let me finish the sketch. And here, if I give through body, it will go both the direction. It will go both the directions. I'm going to give through body. Okay, let me see whether yes, it's taken both the sides. That is the beauty. Okay, now the final steps what we are going to do is to give edge blend. It's what we call, here it is, let's give 3 mm. Okay, 3 mm first to this edge and then to this edge and then to this edge. This is how, this is the way to apply holes, and we should do it last after creating all the extrude underballs. Okay, and here also you'll see one more thing. I given edge blend at 6 places, both sides, and I'm going to give edge blend now one more time at 2 places. You see, only this 3 mm, not taking it. Let me give 2 mm, it's taking it, no issues. And I'm going to give here also. Okay, now it looks nice. Yes, and one more edge blend at 6 mm. Okay, at two edges. This edge, this edge, and this edge, this edge. Okay, apply it. One more edge blend with a 15 mm at four corners. This one, this one, this one, and this one. Apply. We don't have any more edge blend work. That's it. We have created a crankshaft using all the features in the part modeling. Okay, this hole is failed. Why? I check edit parameters. Position is not fixed or what? Why? This is on this line, right? It's not in this line. Let me make this point to coincide with this. Okay, let me make these two horizontal. These two horizontal. Then let me make this point to coincide. It's already coincident. Okay, and let me give one more constraint here. From this point to this axis, it is strong, right? 12, not approximate. Perfect, because we have done symmetry. No issues. Over constraint then maybe. It is over constraint then. Something is showing error. No problem. This is the part modeling of crankshaft using almost all the part modeling features in this exercise. You practice it, you can make any part, any 3D model if you learn to make one crankshaft. Thank you for watching this video.